So absolute value is a distance from 0. Distance is a measure. Measure is always positive. So I'm about to write down all the stuff that I said don't write down. Just look. So we have this absolute value here that I highlighted in yellow. But I want you to imagine for a minute, or you don't have to imagine because I'm going to actually literally write it down. That instead of that yellow highlighted stuff, let's say I just had one single variable there instead, like I had an x. So everything else about the equation stayed the same. Like I have the 3 in front and the minus 14 equals -2. Now, if you wanted to solve that equation, you would add 14 to both sides. Have 3x equals 12, and then divide by 3, and have x equals 4. Okay, and that's grand. But what's going on with absolute value is instead of that x, so now let me put the highlighted stuff back in, all right? Remember I had put x instead of absolute value of n minus 5. So it's really like now I have this absolute value of n minus 5. Whatever is inside there, the absolute value bars, is going to have to equal 4 once you take the absolute value of it. So what I mean by that is this. Actually, let me wait till we actually work the problem. So actually, I wish I had said this part at all. I wish I had stopped right here. Right there. Here's what I meant to say. Scratch the last 30 seconds from the record. Those are the steps you use to isolate the x. We're going to use the same steps to isolate the absolute value. That's what I wanted to say. So if you go back and look at the words that I skipped over a moment ago, this is step 1. Isolate the absolute value. So let's go do that for real this time. Step 1, isolate it the same way as if it was just an x there. Instead of absolute value of n minus 5, you add 14. So now you can write. Now you're writing on your notes. You add 14 to both sides. And then you have 3 absolute value n minus 5 equals 12. And then make a note somewhere on your paper. This is very important. Do not distribute with absolute value upon pain of death. Just kidding. Do not distribute with absolute value. It would be okay if everything was positive and everything played nicely, but when you start adding negatives in places, then it gets weird and it will mess up your actual answer. So just avoid it in the first place, and then no bad shall come to you. So divide by 3 here. And you have absolute value of n minus 5 equals 4. Okay, so that's grand. Let's go back to the words, to step 2. Step 2 is kind of like only applies sometimes. It says this. If your absolute value is equal to a negative number, you can stop and write the empty set as your answer. Now, that's not what we have in this problem, but I do want to talk about it for a second. So if instead, so here's what that's saying. You could, this is a side example, like I'm making up something else for a minute. If you have the absolute value of x equals -4, there is no number that you can put in for x that, once you take the absolute value of it, would then equal -4. Absolute value will always, always, always be positive. So because there's no number you could put in there, we would say it's the empty set. Okay? Because if I put 4 in there, the answer is 4. If I put -4 in there for x, the answer is still 4. So that could never You could never have a solution in that sense. Now that doesn't apply here, but I wanted to explain the step 2 because it's positive 4 on the right. So step 2 does not apply, not applicable. So then we're going to do step 3. I want you to take a second and just read step 3 to yourself before I talk about it, because I want your brain to have a moment to process it. So let's go look at that together now. Now that you've read it once. So you check step 2. The constant on the right-hand side isn't negative, so you don't have to do step 2. So you go on to step 3, and it says, otherwise, write 2 separate equations. One of them you write by just dropping the absolute value. That's the only thing you do. And the second equation you make by dropping the absolute value and switching the sign on the number that's on the opposite side. You're going to make that number negative. And I'm going to show this to you and explain to you why this is a thing. So I have this equation here, the absolute value of n minus 5 equals 4. That stuff inside the absolute value, the n minus 5, we don't know what it is because we don't know what the solutions for n are, but whatever it is, it has to equal 4. Because if it was 4, and I took the absolute value, it would equal that, positive 4. So I just take that stuff outside. I'm just talking about it. That stuff inside is n minus 5. Why does it switch to the calligraphy pen? Like, I did not make it. The stuff inside, the n minus 5, and equal 4. So I make an equation like that. This is me just dropping the sign, the bars, not doing anything else. This is my first equation. However, so I'm going back up to the highlighted stuff. That stuff inside could also be negative 4, right? And if I took the absolute value of negative 4, it would still equal positive 4. So I take that stuff inside. This is my second equation. That stuff inside, the n minus 5, can also equal negative 4. So this is why we have 2 different equations. We drop the signs. One equation, the 4 is positive. One equation, the 4 is negative. What you're not ever going to do, going to do is change the signs on the stuff inside the bars. It's only the constant on the right. It's only this thing that gets a sign change. So then step 4 says to solve both of those equations. So on the first one, I add 5 to both sides. And on the second one, I add 5 to both sides. And I get 1. But read step 5 to yourself, please, so you can be ready for what I'm about to do. I'm about to write it in set notation. Sets get squiggles. And we write it in numerical order. So 1, 9. Any questions about anything I did there before you try one on your own? You can put it in the chat. Okay. Try the next problem, please. And if you're working asynchronously and you're watching this video later, please pause the video now. So here's my work. You should have negative 2.15, negative 2.85. The last step, though, to put your answer in set notation. And when you're putting it in set notation, they're both negative. Remember that if you're going in numerical order, the number that seems bigger is actually the smaller one because of the negative. So the negative 2.85 should be listed first. Any questions about that one? Raise your hand if you got that right. Raise your hand if you got that right and you got the squiggles right and you listed the negative 2.85 first. All right, like a boss. Okay. Please try the next problem. Does anybody need the screen up before I switch to the other problem? I don't see any hands. Okay. All right, spend a few moments on this one. Be sure you follow all the steps on this step. So this problem wasn't really like hard as far as algebra problems go, but there is one thing that you had to have been paying attention to. So we add 14 and get negative 5, absolute value of 2y equals 20, and then divide by negative 5. You must resist the urge to distribute the negative 5 at all costs. And we have absolute value of 2y equals negative 4. This is where step 2 kicks in. Go read step 2 with your eyeballs into your brain, please. Step 2 says if your absolute value is equal to a negative number, you can stop and write the empty set as your answer. Done. Because there's no number we can plug in for y that will give us negative 4 after we take the absolute value. Absolute value can always and forever only give you a positive number. So that means there's no solution to this. And the thing that's tricky about, it's not tricky, it's just there's no trick. But what's troublesome is you have to be on the lookout for that every time you get to this part of your equation, because in green, I'm going to put what would have happened if you just kept on going. You might have told yourself, all right, well, okay, so this is bad math alert. You don't write this down. The BMA. Unless BMA stands for something awful, and then it's not a BMA. So you might have thought, okay, she said we make an equation where we drop the bars and we make a positive version and a negative, and then you would have solved those and had 2 and negative 2. And there's no thing that alerts you to the fact that that's bad except for yourself checking on step 2. So don't go into like autopilot and just forget to check for that, because you'll get an answer and go about your merry way and think that you were good, and you weren't. You were bad. It was bad. It was bad all around. Questions about this problem? Will you put in the chat for me if you didn't get it but now you get it? Would you put like good in the chat? Because yeah, okay. All right, perfect. So the other 2 problems, I didn't get it, but I do now. Perfect. That's called learning. That's what we're here for. So look at this problem on your notes. We're not going to do that because we want to leave class early. That's why. And but also because it's pretty repetitive. Like I wouldn't have cut it out if it wasn't. but it's just like problems we've already done. The only thing is it has decimals, but I'm not afraid of decimals, and I don't think you're afraid of decimals. But I do think you might be a little bit afraid of fractions. So we're going to do the fraction problem, and then we're going to have our quiz. But let me write the answer down for here in case you did it and you just want to know. It's negative 16.2 and negative 2.2. And if you want to see it worked out, the completed notes are in your Google Classroom. In the stream announcement, I have a copy of my filled out notes if you just want to see the work. In case you did try it, you didn't get that, and you want to find your mistake. Otherwise, we're going to go on to the fraction problem, which is this one. So this, you do everything the same. You don't even have to deal with the fraction for the first few steps where you're just trying to isolate the variable. So you get yourself to the isolated part, and I'll get myself to the isolated part, and then we'll come back together. I don't want to. I'm the boss of the smart board. That's my self-affirmation for the day. I'm the boss of the smart board. I know I said I was going to let you get to the point where you were isolated and then we'd come back together, but actually I changed my mind. I'm ready to talk about this step right here first. Right here, you'll see I have a negative 6 on the right-hand side, and you might be thinking to yourself, she just said, if the number on the right is negative, that I can stop and that there's no solution. And I did kind of say that, but here's why it doesn't apply right now. Because I have not finished isolating the absolute value. What happens, so I still have a negative 2 to divide. And then when I do that, look at what happens to the sign of the number on the right. It becomes positive. So negative 6 divided by negative 2 is positive 3. Now my absolute value is isolated. Now is when I ask myself, does the absolute value equal a negative number? And the answer in this situation is no. So sadly, we just can't stop right here. We have to keep going. I didn't change to blue. I don't know how I did that. I thought I was the boss of the smart notebook. So here's where we make our two equations. Now it's purple again. I don't know what's going on. Drop your absolute value. One version where the constant on the right stays positive, and one version where the constant on the right stays or goes negative. And again, because it bears repeating, you never, ever, 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 ever change the signs of the stuff in the absolute value. It's always, 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 always only the constant that's on the right side of your equation. That's the thing that's getting a sign change. And so then we just solve these. The equation on the right, you subtract 3 from both sides. There's an absurd amount of 3's in this problem. So negative v over 3 equals 0. And then to get the v by itself and make it positive at the same time, I'm going to multiply both sides by 3 negative, right? The 3 part cancels out the 3 on the bottom. The negative cancels out the negative. And so that gives me positive v on the left and 0 on the right, because anything times 0 is 0. And then for the second equation, we go through those same steps, subtract 3. So now I have negative v over 3 equals negative 6. Multiply by negative 3, the negative cancels out the negative. The 3 cancels out the 3. The 3 on top cancels out the 3 on bottom. So on the left, see, why is it changing color? I don't know. So that's V equals 18. And the very last step, step 5, is to write it in set notation, which goes like this: wiggly wiggly, and then 0, 18, squiggly wiggly. Any questions about that problem? All right, so this homework is not for a grade, but you are responsible for the material. You are responsible for coming into tutoring if you need help on the material. The only new thing we're learning next week is called absolute value inequalities. And it's like this, but it's like a little more intense. And we're going to be spending a little bit of extra time on that because everyone usually needs extra time. So start working on your test reviews as soon as you want to, understanding that some stuff on there you haven't got to yet. So don't stress it. We'll get to that next week. I'm going to go over to quizzes now and make your quiz live and assign it to your classroom.